Podcast is now starting. All attendees are in listen-only mode.
Hey everyone, thank you so much for joining us today. Good morning or good afternoon, wherever you're at right now. Today, we've got a great webinar for you using a PL SQL table API to implement SmartDB thick database principles. So if you've got any questions at any point in time during this webinar, please submit them in the questions portion of the webinar control panel. And if time allows, we'll get to them during the webinar, right after, or we can even try to get follow up with you after we've completed. So my name is Monica, and I work for Viscosity North America, a system integration and full Oracle stack consulting firm. We specialize in services such as Oracle Apex and custom app dev, health checks, performance assessments, performance tuning, zero downtime migrations, and we love hosting things such as webinars and workshops. So hopefully you're a little familiar with us already and you've been coming to some of our webinars. So today I'm super excited to host with NYOUG, the New York Oracle User Group. For more information about NYOUG and their upcoming webinars, please visit nyoug.org. You can also visit viscosityna.com/event. We've got so many webinars, like I said. We've even got Peter, today's speaker, presenting again on September 22nd. So be sure to register for his next presentation through NYOUG or Viscosity. And that presentation is called Application UI Design in a Mobile Device World. So with that, let me introduce Peter to you all. Hopefully you're familiar with him as well, and definitely take the opportunity to ask him questions. I always try to push that as much as possible because this is kind of your time with him. So today's webinar is live, it is recorded, and you'll get all of the information you need afterwards, such as his slides, any code he's going to give you, and a video recording of today. So Peter Koletsky is an Oracle ACE director, and he's worked for over 34 years in the IT industry, and he's presented at various Oracle technology conferences around the world, which is over 360 times. Additionally, he's won a dozen user group awards from ODTUG, NYOUG, in ECO or SEOUC. Peter is also an Oracle certified master, UTUG board member, that's the Utah Oracle User Group, and a past board member for IOUG and NYOUG, and he's co-authored variously with Duncan Mills, Avram Roy Faderman, and Dr. Paul Dorsey of 8 Oracle Press, McGraw-Hill professional books about Oracle Developer, ADF, Oracle Forms and Reports, and Oracle Designer. With that, I'm going to hand it over to Peter.
Okay, thank you, Monica. At the moment, you see on my slide, I'm Oracle ACE Director, and I have the New York User Group logo. As Monica said, I'm past board member of NYUEG, and I want to say that it's a great group, and if you're in the tri-state, New York, New Jersey, Connecticut area, it's a great thing to keep track of, so definitely go to NYUEG and check out what they've got. Lots of information from past conferences, and they've got SIGs, special interest groups that you can join. And when things happen in person, you can go to their conferences 4 times a year. And the next thing that usually happens with these presentations is that we talk about our companies, but I'm kind of in between employers now, so the space is for rent. But I think I'll use it to promote Viscosity, even though there's no tie for me to Viscosity. I've just been very impressed with their staff. I know a number of the people that they've hired lately, and they're recognized conference speakers and book authors and experts in the field. So if you need any kind of consulting work, I can't promote my company because I don't have one at the moment, but check out Viscosity. All right, so think about this and see if you've got any background or experience with these scenarios. You've got a legacy forms application possibly built in SQL Forms 3.0 back in the 90s. And at that point, the 6.0 database didn't have PL SQL, so you were writing PL SQL inside the SQL Forms application. And the picture is not Forms 3, which was character mode, but it's a later version. But you may have migrated from 3.0 to 4.5 and 5.0 and 6.0, and then onwards, and maybe even into the 19 and 20s. But you have application code that's still residing in the form itself with little or no PL SQL in the database. Scenario 2, you've got a Java application that's developed by Java developers who also design the database objects, and database access logic's written in Java code inside the application. So again, little or no PL SQL code in the database. Scenario 3, you're using a JavaScript application or developing JavaScript, and again, the JavaScript application, either on the client or server side, accesses the database objects with little or no stored PL SQL. You're doing raw SQL code to insert, update, delete, and select. So the problem with these are that the applications may work well in test and QA, and then when you get to production, they probably work fine. But when the load starts to increase, you might have performance issues because logic that's accessing the database requires a lot of time. You've got multiple messages going back and forth to the database, and that takes extra time. So it may be that change of, you have to do some debugging later and figure out what's happening. Also, if you're changing development languages, which happens in applications, you're migrating, well, one application may be in Forms and it's being migrated over to Java or JavaScript, or you have a JavaScript application that's going to be migrated to whatever the next language in the hot list will be. If the logic is inside the application, you have to have a complete rewrite pretty much to make that happen. So these are things that can be solved with this thick database strategy, where you're storing most of the application code in PL SQL in the database, as much as possible, that is. So what I intend to do today in this hour is to go through a particular strategy that you can use as part of this thick database paradigm. And the first thing is to explain to those who are not familiar, what is thick database? What does that mean, that term? And then we'll talk about this key strategy, which is the table API, which you may have used and you may be using now, but I'll put it in context of thick database. And then I'll go through again a little bit more of the strategic questions about thick database, why you're using it, why it solves maybe some of the problems that those scenarios brought up, and then go through some variations on the technique, and then strategies for implementing the thick database in general if you haven't already done that. So we'll start with what is a thick database. Oh, and as Monica said, the session is being recorded, and she'll send you a link afterwards if you need to review any of this material that's in the slides or in the talk. And then the code samples that I'll show you are also available as a download from that link there, and that'll go out also in the email that you'll get after this session. So a thick database is a code development strategy that really is intended to maximize use of database code, and that the idea is to simplify the code in the user interface, whatever language that is written in. And it means that the user's device is running a minimal amount of code. And the term comes from the year of the internet, way back, I don't know when it was, in the early 2000s, where we were talking about thin client. And when you're using the database more, you really have a thick database, which means a thin client. And it means that the processing occurs mostly on the server side, on the database side. And Dr. Paul Dorsey, who Monica mentioned, is one of the co-authors that I worked on with the books for Oracle Press, was an early proponent of this, and he's also a past president of the New York User Group. He's got the President Emeritus title at this point. So there's kind of a tie-in with the New York User Group and this thick database idea, because he talked about it quite a bit in the early days. The other terms that you'll see this referred to are thick database approach, thick database paradigm, fat database, smart database, or SmartDB. And Oracle actually has picked up on this, and they really prefer the last two terms. SmartDB is one that you'll see on the Oracle website. They have office hours and things that are for oriented towards SmartDB. So those are all the same thing. Those are all the things that we're talking about here. So the important thing is that the realization of thick database principles is up to the practitioner. And it means that there's lots of variations. There's no one way to do this. And what I'll present is what I've used for at a client for over 10 years successfully, and it's worked out very well for the applications that client was doing. And it implements the ThickDB or SmartDB strategies for centralizing code in the database, minimizing the client side, and then also as a sidelight, you can protect your code from tampering. The strategies that you use to set up the code and store it are helping prevent, helping security on the code side. Companion strategy, which I think is very important too, is a system that you use for tracking business rules. Business rules being data validations and things that check the data as it's coming into the database. So usually system requirements or specifications are oriented towards data validations and also keeping whatever system principles the system requires in effect. So a system for tracking tracking business rules rather means that you could be storing these in some organized place like a database. So you'd have definitions stored in a database table. You might have some user-friendly syntax that will be output from that. You could be storing kind of low-level details and then output that in something that users could look at and read with understanding. You can also link business rules to the code implementations and test plans. So you could have tables that would store your test plans and the code implementation names, for example, PL/SQL package names and maybe procedure names, and then tie those to the business rule so you can track that you've actually fulfilled a particular requirement. And then with a little more effort, you can generate code from these business rule definitions. If you've got a syntax that's translatable to some code representation, then you can build a generator that would actually generate the code for you. And actually, Apex, Oracle's Application Express, is kind of built around that idea. You're defining things in definition screens that go into tables, and those are generating code at the end of it from those business rule definitions. With a lot more effort, you can actually read the business rules definitions dynamically, and the code can be generated as the application is running. So this is a lot more advanced, and it takes quite a bit of coding to come up with this kind of system. But there are business rule systems. Oracle has one called Business Rules that stores the business rules in XML, and there's a user interface, a web user interface to define those. And as the application is running, it's checking the XML and then doing whatever action was defined for that particular scenario. But the main technique, back to kind of where we're talking about today, is a database code that implements the business rules in PL/SQL and enforces data integrity and whatever is needed to make sure that the data is solid. And also database views that represent complex business objects. And this simplifies the user interface. So what you're doing is having a view that is a single database object that you can access, and then that view has accompanying code that's written in PL/SQL and activated with a instead of trigger. So the interaction is with the view and the API, which we'll talk about and give examples for. And the goal, of course, again, is data integrity using database objects. And this is all done, if you jump down to the bottom point, because we have a definition for this syntax for create assertion in SQL standards, ANSI SQL, but it's not something that has been implemented in any database language yet that I know of. But if you look at that link at the bottom, that's where one of the Oracle folks is talking about create assertion, just as something that will be maybe added to databases in the future. And the idea is that the application can't corrupt any data integrity. But what we're doing is we're supplementing database constraints, which have some representation of business rules, like mandatory fields and data types. Those are fairly simple constraints that the database can actually do without much additions. And then triggers can also supplement the constraints, but they're still not enough. And if you're doing cross-row or cross-table validation, triggers fall short. There's a lot of workarounds you have to do to make triggers do what you need to. So the technique that I'm going to be describing in a nutshell is just the two pieces, table API and the database views. And the user interface code is interacting through that API. So the table API and the database views form the full idea of the API, but the table API is the thing that does all of the logic. So database views obviously can represent any SQL statement, and with Oracle it can be quite detailed and quite complex. So what it boils down to is put your application code in the database. That's kind of the main lesson here. And this is something that you may be doing already. And, oh wait, sorry. I think there's a question here. Do you get a commission for promoting viscosity? Oh, yeah, I should probably say no, I don't. That was me. That's what I feel about viscosity. All right, so moving on, putting your application code in the database is the main lesson here. And if you don't get anything else out of this, that's really it. And again, you may be doing some of this already, but what I'm describing is something that that I've kind of worked with a lot and has been successful as far as a strategy. So you can compare with what you're doing. Okay, so implementing the table API. Let's see if there's any other questions that are not quite so embarrassing. Yeah, nothing yet. Okay. All right, so first of all, you're protecting the code with multiple schemas. And there's a lot of variations on this. You can use two schemas. One would be a connect schema. So user would log into whatever the application server needs to identify them. And then there would be a database schema that would represent the whole application that is common for all users. And that connect schema then accesses the tables and the PL SQL code that's needed to work on the tables. So the table owner schema is separate. It has limited grants to whatever's needed for the application, just to the connect schema. There's also the idea that you can use three schemas. And again, you have the connect schema, you have a separate one for PL SQL and a separate one for table owner. So there's additional grants that would be done from through those layers, but the more schemas you have, I think the more layers of protection you have. So it's up to you as to whether you think that it's unnecessary to have additional schemas. And we'll go to 4, and this is one that I'm not quite sure that I would ever use, but Bryn Llewellyn in this white paper, Why Use PL SQL, presents a case for why you would want to use a separate table API and a separate business rules code schema. So that paper is worth looking at. And if you search for that particular title and his name, you'll find it. Synonyms are optional. Generally, you want to be careful about too many synonyms because they could point to objects in different schemas that you're not intending to. And then DDL triggers, if you're not familiar with DDL, it's data definition language triggers, which means that you can enforce restrictions on who is doing grants and creating objects. basically. So you're restricting tampering of a particular schema and a particular set of objects. Okay, so the table API. So table API is basically the way that I've dealt with it, it's a PL/SQL package per table. So the PL/SQL package contains procedures for insert, update, delete, and lock. So a user interface can call those instead of issuing a SQL statement like insert, update, delete, or select for update, which would be the lock. So you're dealing with procedural code rather than SQL through the table API. And then the procedure is called business rules validation code to check the data before it is sent to the database, for storage. And there's no grants to the table directly. So you're working through the PL/SQL package. Whatever schema owns the PL/SQL package obviously has to have access to the table, but the Connect schema may or may not have that grant to the table. Okay, so demo one. These demos are just to show code examples, pretty much. And again, that's the short link to get to all the samples it'll show you. It's a zip file you can download. So we're going to go look in SQL Developer. I got to be sure I'm still showing you SQL Developer. It looks like I am. And raise your hand. Well, you can't raise your hand. Put a question in if for some reason you're not seeing what I'm hoping you're seeing. So what we're looking at is there's a jobs table. This is the standard, set of Oracle sample tables. So there's a jobs table, which is a very simple table, actually. I'll zoom in so you can see the columns if you can't see those. The reason I'm using it as an example is because there's only 4 columns. But it's just one of those samples that Oracle gives us for doing standard HR, logic work. So the jobs table has an API package that I call jobs tappy, auth ID definer, which means that the code units in this package are available to can access things that the schema that owns the package is owning. So we're starting with the record variable, which is all the columns in the table, and then a table variable of that record. So we have 2 ways to get to the table with variable types. And then there's an insert procedure that has parameters of just the individual columns or the full row type. And then same thing for update, same thing. And then delete is just one thing because we're passing in an ID and then we're deleting based on that ID. And then the lock, which is a similar thing. So that's the spec. And then when you get to the body, you'll see a statement for a procedure that is called check jobs insert, and we'll look at that in a second. But basically, you're sending the values for this row that the parameters represent, and then it will be doing validations on the data in that row. In this case, I decided to send it in the individual columns instead of the row type, which it's because the input was the columns, not the row type. And then the next thing is if there's a problem, then a validation error, then the error will come back in a message variable. And if the message variable has something in it, it means that that we don't want to do the insert, but we want to somehow handle that error. And the way you handle the error is kind of up to you and how your application works. So what I've had experience with is to do a raise application error. And since this is called from a trigger, it'll go back to the trigger. The trigger will fail, and there will be a SQL error message that comes back with the error message inside of it. And then you can parse out all of the Oracle error numbers around it and just show the message. So if there is no message, then the insert will occur, and then the insert is done. And then you do a commit somewhere, probably in the application code. Same thing for update. The update I'm doing I'm updating all the columns, even if only one of them changes. It may be that you want to figure out which column has changed, so you'd have new and old values for these columns. You'd send those into this procedure as well. But you would also be doing a check procedure. So there would be a business rules check here. I kind of abbreviated it just to give you an example. It would work the same way as the insert. And this is an update with the row type for the full record variable, and then that just calls the individual variable parameter, individual column parameters version. Delete is just a delete with that ID, and a lock is a lock, and it's just an insert. It's just a select as select for update on that ID. So this is a simple version, and again, I'm skipping validations on the delete and the updates, but those would happen like the insert. So you'd have something like a check jobs update and a check jobs delete procedure. In the jobs BR is the name of the package. So the jobs BR package, again, I'm passing in the record, the columns variables, and I have a row type version of the same thing. So in this procedure, in the body, I'm setting up a series of business rule checks, and I have a system where I've numbered the business rules in a table. So I have basically the error message and the definition of the business rule with the number, and then I'm putting that in the comment as well. I have a to-do to externalize the messages. Obviously, if you've got a multilingual application, you don't want to hard code messages, and even if you don't want to hard code messages because they're not as easy to change. But again, this is for sake of example and simplicity. You can do whatever you need to make it work for your system. So the first one is minimum salary must be filled in if maximum salary is filled in. So you can't do the insert and have a maximum salary but not have a minimum salary. So it's a fairly simple business rule, but this is an example of what the type of code you might have here. And it might be that this is a fairly involved business rule, and you might want to have a separate function or procedure for it. And so you modularize that particular piece of code and have another package that holds the individual checks on a particular column. So if the maximum salary is not null and minimum salary is null, then you have an error message. And I'm basically concatenating using a procedure that I've created to a message string. So we start with a message string at the top, and then we keep adding to it with each of these business rule procedures. Well, we can bounce over to that now. There's the error packages here, and it basically has a definition of a start character. Should I zoom in on that? And an end character, which are curly brackets. You can do whatever you want there. And then a delimiter, which is a carriage return. So the concatenate message basically concatenates the previous message and the new message and returns that with a delimiter in the middle. So that's what we're doing here. We're basically just adding messages up as we go if there is an error problem. So the user will see all the data problems at once instead of getting one error and then changing it and then going, I can get another error on something else. And this one is business rule 25, max salary must be greater than or equal to min salary. So we're checking that and then returning another message, same idea. Again, these are very simple. And this one, this is a business rule that you'd have to kind of invent. Why in the world do we have that? But it's just an example. So a job ID is pres, job ID in this case is a varchar 2. Then you issue that message. And then at the bottom, the check function is returning this concatenated string with the delimiters in the start and end. And the reason for the delimiters is that it makes it easier to parse out all of the additional message things that come out if you're doing a raise application error. So a raise application error will give you error number, or a PLS error numbers that you want to get rid of if you are showing this to a user. So that's kind of the heart of the table API. Let's go back to the slides. Okay, so how do you use this? First method is you call it directly from the client or the user interface. So instead of issuing a SQL statement for insert, update, delete, you would say, jobs tappy dot ins, INS, which is the insert instead of the insert. And then the parameters would be whatever values the users entered or the UI has picked up from the screen. And then the client would perform the commit. The client UI would perform the commit. Some tools are oriented towards SQL, like ADF, and some frameworks issue SQL directly. So you define things in those frameworks that will do the back-end SQL automatically, and instead of doing a procedure call, they do a SQL itself, and you would use method 2 for that. So we'll talk about method 2 next. But the benefit to method 1 is that you have access to any table and statement because you're issuing the calls directly from the UI. You don't have to deal with limitations on insert, update, delete that might be there for, like, if you've got a multi-row situation where you're checking between rows and you're trying to do that from a trigger, you might get a mutating table error. Demo 2 is basically showing that in action. So I've created a tester, which I'll zoom in just to show you the first one, then I'll zoom back out. So I'm calling the insert procedure jobs tappy.ins with some hard-coded values to test each of the business rules that I've defined. So this is kind of what you'd use for testing. And obviously, each business rule procedure would be tested with multiple values. You'd have to issue this more than once, but to try out different limits and different values. But this is just, again, an example just to show how you would pile these up into a testing scenario. And in this case, I'm showing the business rule name or description in an output before I actually call before I call it. So in this case, I'm sending in, we're testing whether min salary is greater than max salary in this case. And in this case it is, so we should get an error message on this particular call. And the exception is only if there's a raise application error issued. Oh, and notice that there's a call to another procedure that I've created, which is called distilled message. And we can look at that in the error package just so you know what it is before we run it. It's basically parsing out the beginning and end characters. And if there's a limiter in on the left, on the starting delimiter, because there was an empty message, it'll parse that out. So it's pretty simple. It's just getting rid of, anything before and after the two curly brackets, basically. That's kind of what it does. Okay, so then the tester also just does the same kind of thing for each of these business rules. So we're doing, and this one is actually testing two business rules, because this particular set of data has a problem with two things. So min salary is greater than max salary, which is wrong, and the ID is pres, which is not allowed. So we should get two messages in that case. So let's run this. Do I have it in the right place? Yeah, let's see. I'm going to run it as a script. And I have to turn on DBMS output and run it. Okay, so here's the output. So these are the DBMS output messages. And the business rule messages that are coming out again, were hard-coded into that the check procedures, but they had come out from the after the validation. So it was done basically to remove basically to parse out the message from that string. So we're getting the error messages for each of these, and then the one that had 2 errors is showing one error message on top of the other one. So it's showing two lines of error message. And this is, again, an example which you can modify it to suit your taste. It might be that instead of doing a raise application error, you're storing the messages in a table, and then when the procedure is finished, you query that table and display the messages somehow. It really depends on the user interface that you're using and how you want to deal with those errors. Okay, so that's method 1. Method 2 is you have a database view. So notice that I said that the method that I've used uses a view, and I haven't shown you the view yet. What we're doing is we were just calling the table API directly from the user interface code. But if you have a database view, then the database view code would call the table API. So the benefit of the database view is that it can be very complex SQL. It can represent multiple tables, and it allows you to do plain SQL. So you can do insert, update, delete on a view and code a row level trigger called an instead of trigger that will intercept the insert, update, delete and do whatever code you've built into it. It is SQL, so you do have to deal with some limitations like row level or cross row and cross table could give you a mutating table error. So it may be that you need to supplement that with other things. Oh, by the way, this is trigger. The horse is Roy Rogers' trigger, so that's why it's in this slide. Probably wondering, why do we have a horse? All right, so let's look at an example of the database view. First of all, I've got another table, which I've created a table API for. So employees, I call it employees package, not employees tappy, but it's the same idea. It has insert, update, delete, lock procedures, and the body has a check insert rules procedure that at the moment doesn't do anything, but it would normally do something like the one with jobs. And then the insert procedure, we're going to look at this variable in a second, or later, not in a second, but later on, has the check insert rules, and then it does checks the error message and does the insert. So just like the one I showed for jobs and raise application error. So the package for employees is very similar to the one for jobs. We also have an employee details VW view, so a database view, which is a join of a lot of tables, actually, most of the tables in that HR schema, employees, departments, jobs, locations, countries, and regions, and just doing an equijoin on the primary key, foreign key combinations. And then there's a trigger on that view, which is instead of update, delete, insert, or update, and for each row, because triggers for views must be row level. And then for the insert scenario, it calls the ins procedure. For update, it calls update, and for delete, it calls delete. And that's pretty much it. So what happens with these is that, for example, the insert, the check procedure happens. If there's an error message, the insert doesn't happen, it raises application error, which means this trigger fails, and the raise application error message will be sent back to the user interface, which has to parse it out. If it hasn't, like I did with the method that I showed you in that tester. So the benefit of this is that you can have direct SQL instead of using procedure calls, you're issuing SQL to the view, insert, update, delete, and you can also select from that same view, obviously. So it gives you a standard SQL access path. Okay, so this is just a picture of the flow, which we just kind of looked at in the code. So the DML in the view, DML being insert, update, delete, and it's in quotes because DML technically includes select, but DML in the view hits the instead of trigger, which protects the view, and then the view will do whatever it needs to do to the tables that are involved or not involved with the view. I just showed you the table API for the view, and the trigger only calls the table API for the view, for the employees table. But that join view included countries, departments, and all the others, so it could also make changes to the other tables as well. So in the case that I was showing with the view, I think there were 6 tables, so there would be 6 different APIs that I could call, and any other API if I wanted to. And then that would do the insert, update, delete to the table, and then the table might have a trigger that does something else. It would probably just have an enforcement that nothing can get to that table through other means. And I'll show you that little protection piece of code. Oh, we can do it now. It's probably easier because we're talking about it now. So it's a separate employees. TRBR. Okay. So I mentioned the employees package had that global variable in the spec here, which is called allow DML, and it's set to false initially by default, but the table APIs set it to true before they do whatever they're doing, like an update or an insert. And in the view trigger, in the table trigger, we're getting there. In the table trigger, if that global variable has not been set to true because you're not going through the table API, then you raise an application error. So you may not issue insert, update, delete to this table. That would be the error. So it protects the table from having calls outside of the table API. Now you're saying somebody could just disable that trigger, either temporarily or permanently, or they could delete the trigger. And that's why you've got all of those additional schema protections, the grants and the DDL triggers that will help enforce that somebody can't go in and modify this trigger. But that said, if those are rigorously applied, you probably don't even need this trigger. So in the slide here, I put this little thing up here so that you can see that the table trigger is protecting the table from insert, update, delete outside of the table APIs. Well, so you notice that the table APIs for the jobs and employees tables were very similar, and it turns out those tables are fairly simple. You may have a table that's got 200 columns in it. That's going to be a lot of typing and possibly a lot of mistyping and possibly some errors that are typo errors that are occurring because of that. So what you want to do is have something that helps you generate that code, and you can create your own generator, but there's a bunch of built-in generators that you can use, and I've listed a couple that are out there. You can use your own. I mean, basically what you're doing, I'll show you, is you're querying the data dictionary. So you create a package around statements like this that will collect details from a table and put it into a template of some type to create those insert, update, delete procedures inside the package. And it's just a what you would expect as far as querying the data dictionary. But again, it's been done already. So these are two sources, but SQL Developer has one too. So if you've already created tables, you can go into SQL Developer, and let's do this for departments. And I'll zoom in. I'm looking at the schema and then tables node, and then on that particular table, you right click, and under table, you select generate table API. Let me zoom into that. So generate table API. All right, I'll do it again because I got out of it when I zoomed in and out. Okay, so here we are. So it basically created, well, and what I always do is Control F7 in SQL Developer reformats. So I always like to do that because I like this formatting better than the default format. Basically created the things that I was showing you before. It doesn't have the check procedures, obviously, because that's something that you would put in later, but it gives you all the stuff that you could possibly mistype, and it does exactly what you would be doing with your data dictionary queries, which is in fact how it creates all of these things. So it creates the record variable, creates the table variable, creates the procedure stub, it creates specs, and then the body for all of that. There is something interesting though. If you do it like on the employees table, I always go to quick DDL, which is the data definition. So I just did it on the employees table. You'll notice in the delete procedure that it uses the email instead of the employee ID because it's a unique key. So it'll pick unique key columns as the keys for deleting, and updating is the same. This is the update. So the workaround, if that's not what you want to do, it may be what you want to do, but if that's not what you want to do, you then disable those constraints or drop them and then recreate them after you've done the table API. But this gives you a great starting point for the code that you want to add for checks. And basically, you could probably even take this code and run it through your own generator to insert the additional pieces. And that'll give you a good basis for at least the kind of boilerplate stuff that you need. And then, of course, you have to create all your procedures for checking data and all that. But that's really up to the application code. So that was that, and that's kind of how you get to it in SQL Developer. Then Quick SQL. I don't know if you've used Live SQL yet, but it's a great tool. QuickSQL.oracle.com is a shortcut to get to this. It's a piece of Live SQL, and Quick SQL lets you enter shorthand definitions for database objects and then create the code for that database object. It's an Apex app, and you use your Oracle login. And if you don't have one, you create one for free. A couple of YouTube videos are out there for this. But the shorthand syntax will create code, and I have an example. Well, demo 6, we'll show this here in the screen, in the slide. I'll zoom in. First of all, the syntax. You see departments and then /API means that we're creating a table API. And then the columns underneath it, you have names and you have shortcuts for the table, the data types, and then NN is not null. Best thing to do is to click the samples button and look at what they've done for samples. But you'll see, at least on the right, a little bit of the API that's created. And it's very similar to what we're doing in SQL Developer, although I like SQL Developer a little bit better from the standpoint of being complete. This will do also triggers and give you a kind of boilerplate stub code for triggers. And lots of other stuff. Now, but this kind of relies on you creating the shorthand code for it and then wanting to create the table from that. Whereas it may be that you've already got the tables and you just want to create the table APIs, in which case you would use SQL Developer. Wrong. Okay, back to, see if I can get back to my slides. I must have closed the slides. Okay, so we're going to go back to that section. Okay, now let's see if there's questions before we go into the wrap up here. Oh, I think there is a question. I can't really read it. Ah, here we go. Okay, let me read this. It's a little long. Absolutely agree with this approach and have for many years. As a DBA, the consistent challenge I encounter is the approach itself is not the approach itself, it's the culture of the developers. Ah, they don't want the database to handle the business logic, preferring to code everything themselves, plus management don't want to hire database developers in addition to front-end application developers. The end result is inconsistent and fragmented application, which doesn't scale and performs even worse as load increases. By the time that happens, it's the DBA's problem. Sound familiar? What advice do you have for overcoming environments which are dramatically opposed to doing things properly? Oh, I shouldn't laugh. I know it's unfortunately common, and it is a big problem, and it is the DBA who has to kind of bear the brunt of this. I'm going to address that briefly in the variations and strategies section, but so let's go through because the person who asked this question is already kind of sold on it. We'll go through the why we use the thick database approach fairly quickly and just give the benefits for those who haven't gotten the picture yet. Faster performance, and our questioner asked that. The code is close to data storage and few messages. Views reduce the number of round trips back and forth. So you're saving cloud costs because there's less computing costs, and you're saving time on the computing side. And then proper use of staff. If you have database code developers, and sometimes you don't, but if you do have database code developers, then they can concentrate on the stuff they know the best. The UI people can concentrate on what they know the best, and it can actually simplify greatly the user interface code because you don't have to write all the calls to the database. And then if you're rewriting, I mentioned this before, it may be that you have to change your technology for the whatever application is written in, and it's much easier to do that if most of the application logic is in the database. Table refactoring is easier because you can do that with just a change in the database without having to modify the application code and redeploy it. So this works for all different types of code paradigms, all disciplines. It may be that there's a layer in the middle, like ADF and Mobile Application Framework, JavaScript, have something in the middle of the call to the database, but something like Apex and Forms go directly to the database. But there will be common usage of that API, even if there's multiple types of code going to the database. So Tom Kopelars has done a bunch of research to figure out, I guess, metrics for what the benefits are of using this thick smart database approach. He calls it smart database because he works for Oracle. But I'm giving a bunch of links and references to his work. And the main test that he ran that's of interest is comparing a row-by-row processing application, which is millions of rows, for one that was written in plain Java without a framework, and one that was written in PL SQL, which you wouldn't do row by row in PL SQL, and then one that was using set processing. And again, SmartDB is what Oracle is using. So 5 million rows, and there was no app server process on the PL SQL side, but the JVM on the Java side had a lot of overhead with these individual row by row things. So the elapsed time was 3 times faster than for thick database than for the Java, and the CPU time or usage was twice in the case of the Java. So you're saving not only the time, but you're also saving CPU cycles because there's this Java startup and shutdown. And this is the chart. He did a flame chart which shows the individual times for each of the method calls and each of the statements. And the row by row, the total time was 204, I guess, seconds for PL SQL, but 437 for no PL SQL, which is the Java. And then if you do set-based, of course, it was very little. It's just 7. So there's a big benefit in the timing and also the processing. So drawback are time and effort. You got to figure out, what's form of the strategy you're using, and then it is helpful to have a database designer and architect who knows how to do this stuff, an expert coder to develop the engines to run or generate the business rules code, and then buy-in from management. So that's the thing that the person who asked the question didn't have either, because you never have time to do strategic stuff, right? You're always working on applications. And also, if you're dedicated to database independence, which is a problem, because then you can't really switch databases if you've coded everything in the database. For example, switching from Oracle to SQL Server, you're limited. So that may not be when you want to use it. And then if you have fewer simple business rules, it probably doesn't make sense to go into that overhead. I'm not sure that's possible. Maybe there isn't an application that has simple business rules. Oh, and this is a good quote from Yogi Berra. Just because, we're talking about thick database. The towels were so thick there I could barely close my suitcase. And that was for the Marriott Marquis. So variation is calling a PL SQL function for select. So we just looked at insert, update, delete, but you could also have one for select. And that would give you the option to do some kind of validations on access privileges or something. But the virtual private database policies can do that too, and that's probably a better way to do it. So it's an option anyway. And then I showed this example of the global variable that lets you enforce that only the table API calls the insert, update, delete. So that's the code again, and the table API sets that variable to true before it does the insert, and then sets it to false afterwards. And then it's set to false for any other type of access in that session. Do you need an Oracle database? Well, it's helpful to have a central location for the code, and it could be that the code is somewhere external, but having it in the database is definitely a benefit. All right, so how to transition, and this is starting to answer the question about how do you get buy-in from developers. I think showing and maybe digging into Toon's research, and he does have a video that shows a lot more about how he made the application, how applications could be a lot more efficient. The ability to be more efficient might be one of the selling points, but it does require buy-in from all parties. So it is. I don't have a lot of advice other than trying to sell the benefits to the application that way. As far as ease of coding and initial ramp-up time, there's going to be some. So it's just that way with any kind of strategy. But it's hard to do this with an application that's already running. It's better and easier to do it with a new application and something that's small. So the best way to do it is, think about something that you can work it into and kind of get benefits from right away. That's something new, and then maybe enhancements to existing applications could use that strategy. So I guess, again, if you have a database developer, database developers can focus on this part, and then the UI developers can focus on the UI part. But it's normal that each of those groups doesn't have key skills in the other disciplines, basically. So if you're a UI developer, rely on the frameworks and don't try to write outside of those, but kind of understand that there is a benefit in in the strategy. And for database developers, it's helpful to know what the points are that you're hooking into the UI. You don't have to know the UI language in depth, but being able to communicate with the UI people is good. And again, this is all assuming that you've got the two different types of people. All right, so I'm just going to go really quickly through these because it's not worth spending time on. We're running a little bit over, but you can look at these links later. So these are all really good ways to get more in tune with PL SQL in the database. So I'm going to look for questions, and then I'll give you the summary. And I don't see any more questions. So, all right. So in summary, the thick database approach emphasizes database code. Basically, you're saying, let's put as much of the logic that the application needs in the database, which, because it's closer to the database, there's fewer messages going back and forth. There's ways to make it more efficient that way. So you can improve the UI simplicity because you're offloading some of the code to the database side. The productivity can be better if you've got the two types of people that are working on your application. They can each concentrate on what they're good at. System performance, obviously it's faster. Application accuracy, if you're tracking the business rules and you can prove that you've fulfilled the application specs by looking at the code and making sure that you've represented all the business rules. And security, you saw the ways that you can protect the code through the different schemas. But there's no one way to implement, so it takes some doing to figure out how you want to do this. The table API is the core technique, though, even though you may implement it slightly differently, this is where you're going to probably focus with the table API and business rule procedures. And then calling table API from view triggers or the UI client, methods 2 or 1 respectively, but it takes some ramp up time. So using a phased approach is kind of helpful. Okay, again, code samples are there, and slides will be also at NYOUG.org. They put those out at some point, but Monica will send the links to the slides in the recording later. And one last check for questions, and then we'll just, nothing left. Okay, but again, you can email Monica. You have her address from the invitations if you have any questions later. So thank you for attending, and I'll turn this back to Monica.
Thank you so much, Peter. Any questions that have come in that he didn't get to, or additional questions that you might be putting in right now, I will have a list of them to hand over to Peter. So definitely get them in. Last call right now. And thank you again so much, NYOUG, Peter, and all of our attendees today. You will get a follow-up email from someone on my team, and they'll send you a link to rewatch today's webinar and a link to grab his slides. And I think that's about it. So if you have any other questions for us, you'll get an email from us where you can respond there. You can also email us at hello@viscosityna.com. And again, as you see on the screen, NYOUG.org, best place to go. Keep signing up for these webinars, and they'll have a copy of his slides as well. So thank you again, everyone. Have a great week, and I hope we see you again next time. Thank you.